Hello everyone, welcome back to another lesson. Today's learning goal is I can graph piecewise functions and step functions. So we're going to be learning about what piecewise functions are, okay, and step functions. So here it says a summer camp pays its counselors based on the years of experience. The function f represents the amount a counselor is paid with x years of experience. Read descriptions and write the domains for each function as an inequality. So the first one says that they get $1,000 if years of experience is less than or equal to $3. So that means that no matter what, if they have 3 or less years of experience, they get $1,000. Then it says they get $100 more added on for each year greater than 3 years. So when it's greater than 3 years, so x is greater than 3, if it will let me do that, then they go by this formula right here. This is called a piecewise function because depending on what x is, the equation is different. So a piecewise function is defined by pieces of different functions for different intervals of the domain. So here it says fill in the domain constraints from the summer camp function. So it might look something like this. 1,000 when x is between 0 and 3, including 0 and 3, and 100x plus 1,000 when x is greater than 3. So piecewise functions can look like something like this. So here, x minus 1 when x is less than or equal to 2. Okay, and so this part right here is that. This is negative 2x minus 1, and then negative x plus 4 when x is greater than 2. Notice how there is a open spot right here because there's no underline right here, as opposed to over here where there's an underline, we have a filled in dot right here at 2. Okay, so number 1, a piecewise function f of x is shown below. Graph A shows the equation y equals 2 and y equals x. On the graph, highlight the portions of each equation that are defined by f of x. So it says 2 when x is less than or equal to 2. So if we want to highlight that, that would be, we would go right here to right here until it gets to 2. And then it says x when greater than 2. So we go from here to here. Put arrows at the end, and says sketch the highlighted pieces of each function on the coordinate b. So right here we have starting from here to 2 all the way here, and we have a filled in dot. And since we have a filled in dot, it doesn't matter but that this is an open dot for the other part. So we just go up from that all the way through. Sketch a graph of g of x, where g of x is negative x plus 4 when x is less than or equal to 0, and 3x when x is greater than 0. So here, let's start at 0. And by plugging in 0 into this equation right here, we find that at 0, x equals 4. And we have a filled in dot because of this right here. Then we have a slope of negative 1. So that means if we're going to go backwards, that's going to be going upwards like this. And then we have 3x when x is greater than 0. So if I plug in 0 right here, it's going to be 0. So that's going to be an open circle because it doesn't have the underline. So it's an open circle right here. And with a slope of 3. So over 1, up 3, over 1, up 3. And it goes like that. It says, is g of x a function? Explain your reasoning. Well, here we can see that if we use the vertical line test, remember that tells us that for every single x value, there's one and only one value. There is no overlap. Right here, you might think there's an overlap, but this is an open circle, just like when we're graphing inequalities on a number line. So therefore, the only point here is 0, 4, and there's no point here at 0, 0. So therefore, yes, it is a function. It passes the vertical line test. Describe each function as continuous or discontinuous. Justify your answer. So f of x, which is back here in question number 1, f of x, right here, you see how there's no gap in between the two parts. It's all connected because where 2 ends right here, the next function next part of the function picks it up. As opposed to right here, there is a gap, so therefore this one is discontinuous because there's a jump or break in the graph, while f of x is continuous. There's no break in the graph. A special type of piecewise function is called a step function. Okay. In 5 and 6, graph the step functions and find the domain and range. So here it says we have f of x or g of x is -6 when x is less than or equal to -2. So we'll graph that part in green. So it's -6 when x is less than or equal to 2. So we're going to have a full dot right here and go backwards because it's less than or equal to -2. The next part says 1 when it's between -2 and 3, including 3. So 1, which is right here. So we're going to have an open circle right here. And over to 3, which is a full circle filled in like that. And then that's our blue part. And then we'll do the last part in red. 7 when 3 or greater. Or greater than 3, excuse me. So it's going to be open dot at 7 right here, going that way. So this is called a step function. That's because all these have a slope of 0. Okay, all parts of this has a slope of 0, and it kind of looks like steps going upwards, or you can go downwards too. But here it kind of looks like steps. The domain, as you guys can see, well, it goes over to infinity this way, it goes over to infinity this way, and there's no gaps in between. So therefore, it is all real numbers. The range, well, we only have y values of 6, 1, and 7. So therefore, -6, 1, and 7. Here, we're going to graph this one. X is less than -5. It is -3, so we're going to have an open circle because there's no underline right here. So -3 and -5, so -3 and -5 right here. The next part says -1 when between -5 and -1, including -5 and -1. So we're going to have a point right here filled in. And again, filled in over here at -1, right there. Then the last part, 4 when greater than -1 and less than or equal to 5. So that's going to be 4 at -1 with an open circle, and then 5 right here, and a line. So here, the domain is going to be everything less than or equal to 5 because we have the vertical line test works, or there's a part of it for everything except for greater than 5. And then the range, we only have it at -3, -1, and 4, so therefore our range is -3, -1, and 4. So describe the characteristics of a step function. A step function is a piecewise function containing only constant pieces. Like we said, the step function is always discontinuous and has the appearance of stair steps, like we said before. Here it says sketch a graph of f of x. So here we have -x when less than or equal to 0. So let's plug in 0, because that's our last one here, and it's going to get us 0 right here. And then we have a negative slope of -1. So if we go backwards, it's going to look like this. And then we'll graph the next one in blue. X when greater than or equal to 0, or greater than 0, so theoretically an open circle, but it's already filled in from the last function. So this is going to be a continuous one, and it has a slope like that. It says list the following attributes of f of x. We have a y-intercept of 0, 0, a domain of all real numbers, and a range of x or y is greater than or equal to 0. Notice how this function actually, and we saw this in your homework or the classwork the other day, is actually the same thing as f of x is the absolute value of x, because if we were to put the -3 in here, the absolute value of -3 is 3, so -3, 3. Same thing with negative 2. Negative 2 would be turned into 2. Negative 1 would turn into 1. And then 1 would be just 1. 2 would just be 2. 3 would just be 3. So this is also known as we'll call this f of x is also known as the absolute value of x. So both of this, all of this, let me use that in a different color so you guys don't confuse that with just one part of it. All of this, f of x equals the absolute value of x. And we'll deal more with this type of function later on in the year.